Alright, geometry, moving on to lesson 2. We're in module 3, little reminder. Now we're going to take what we learned yesterday and talk a bit more about area, just properties of area. Little basic sort of reminders of how to calculate area of a triangle. Area equals 1/2 base times height. On a right triangle, the height is the distance from one of the sides of the triangle to the vertex that forms at a 90-degree angle. If it's not a right triangle, you need the altitude, which is the distance from a vertex to the opposite side where it forms a 90-degree triangle. You need one of those two measurements. Sorry, label it. There we go. Luckily, these two are 90-degree triangles. So we can say area equals 1/2 times 8.4 times 12.6. So let's calculate that really quick. I have 52.92 units squared, excuse me, for that triangle. And this one, it looks like they are the same measurements, right? So do I need to calculate it again? It's sitting on the 12.6, so I'll use that as base, and 8.4 seems to be the height. And it's the same. I didn't even calculate it, sorry. Remember, multiplication, I can go in any order. It doesn't matter. A times B is the same as B times A. Circle the transformations that, if applied to the first triangle, would always result in a new triangle with the same area. Okay? Translation, rotation, and reflection, these are all called rigid transformations. They don't change the scale. They don't change the size of the sides. The distance between 2 points are always the same on rigid transformations. Okay, a dilation is not a rigid transformation. Oh, and that was my explanation to part B, because they are rigid. Two congruent figures, because they're rigid transformations. Two congruent figures have the same area. If two figures are congruent, it means that there exists a transformation that maps one figure onto the other completely. So it makes sense they have equal area because they're covering the exact same region. Calculate the area of the shaded figure below. What kind of figure do I have here? I have a triangle, a rectangle, and another triangle. Well, the triangle is, so the area of the triangle is 1/2. The base looks to be 3. And the height looks to be 3. 3 times 3 is 9. Half of that is 4.5. I have 2 of those. And then I have the rectangle. Area of the rectangle is base times height. So, or length times width, I'm so sorry. Length times width, which is 21. So 4.5 plus 4.5 plus 21 is 30 units squared. How did we determine this? Well, I found shapes I was able to calculate the area of. And I added them together. So really the sum of the shapes, 2 triangles and a rectangle. two triangles, triangle ABC and DEF, are shown below. The two triangles overlap, forming DGC. The base of ABGEF is composed of the segments of the following lengths. So we have AD is 4. See if I can just color code them. DC is 3. CF is 2. So calculate the area of the figure ABGEF. So let's look at this. I need ABGEF. I want the area of the whole thing, right? Well, if I add the area of this triangle with the area of this triangle, that's awesome, except I've added this piece twice. So I think I need to subtract that out. So I'm going to have this big triangle plus the medium triangle minus the little triangle, because by adding the big triangle and the medium triangle, I've added this piece in twice, right? So let's calculate some areas. Area of ABC is 1/2. Let's see, ABC, the base is 7. You see that? 4 plus 3. The height is 4. 7 times 4 is 28. Half of that is 14. The area of DEF is 1/2. The base of DEF is 3 plus 2. 5 times the height, which is 2. 5 times 2 is 10. Half of that is 5. And then the area of DGC, 1/2 base times height. That gives me 1.35. So the area of the figure, well, let's be responsible. ABGEF is going to be 14 plus 5 minus 1.35. Okay, and I explained how I determine it, and then the calculations. Units squared. Oh. See previous slide. Previous, that's awful. A little bit better. Okay, do you see where we're going with this lesson? So I've got lots of areas that I need to like add things together or subtract things apart, etc. For this one, it looks like I have a rectangle with dimensions 21.6 times 12. And then a triangle with a base of 9.6 and a height of 7.2 cut out of it. And we're trying to find the area of the shaded region. So what I'm going to do is calculate the area of the rectangle and then take away the cutout, subtract the area of the triangle. So area of the rectangle is based, or length times width, 21.6. 12 times 21.6. 259.2, and then the area of the triangle, 1/2 base times height. 9.6 times 7.2 times 1/2, 34.56. So I'm going to subtract those. And I get 224.64 units squared. Makes sense? Oop. I explained it. Sorry. In this lesson, we are learning how to add the area of known shapes together to get the area of a bigger shape, or subtract out area of shapes. Oh goodness. Area of shapes to get final area. Okay, you're taking away pieces of area if something's cut away, or you're adding in pieces of area if things are together. But that's all we have for today. So we'll try a problem set and see if we have any questions.